Here are the answers for the section 9-9 homework. Number 1, we have a bank that pays 3% interest compounded semi-annually. We're asked how much $2,500 will be worth if we leave it on deposit for 20 years. This involves compound interest, and there's a formula for this. So the first step is to write that formula. Then go back into the question and identify the different parts. The 3% means that R is 0.03. Compounded semi-annually means twice per year, so N is equal to 2, number of times per year that the interest is figured out. The $2,500 that's left on deposit is the principal deposit, and the 20 years is the value of T. The only thing we don't know is capital A, how much it's worth after 20 years. So let's make our substitutions. Every number is on the right side of the equation. So with the kind of calculator you have on your desk, you can type this in exactly as you see it. Just be really careful with where you put the parentheses and make sure that you have the exponent up here as 2 times 20, or simply put in 40 as your exponent when you type it. The result is $4,535.04. Number 3, if $2,000 is invested at this interest rate, compounded every 4 months, what will be the future amount after 10 years? So a very similar situation. We're going to use the compound interest formula again. Let's identify the different pieces. This is the principal investment, the money you put in to start the investment. 3% interest means that R is 0.03. Compounded every 4 months means 3 times per year. So right there you got to be careful to correctly figure out what it means every 4 months. The letter N is number of times per year. So N equals 3, not a 4. What will be the amount in the investment after 10 years? So that's your T. The letter A is the one we don't know. The principal is 2,000. Fill in the R. Fill in the value of N. And fill in the value of T. Again, every one of these numbers is on the right side of the equals, so type this expression in exactly as you see it. And the answer is $2,695.69. Number 9 is not a compound interest problem about money, but it still involves exponentials. So it talks about energy and mass are related with this equation, E equals mc squared, a really famous equation developed by Albert Einstein. C is the speed of light, M represents mass in grams, and E is representing energy. We're asked to find the energy, so find the answer for E when the mass is 3 grams. So M equals 3 grams. Let's just substitute into our formula. In place of M, fill in the 3. In place of C, fill in that speed of light number that's given to us. All of these numbers are on the right side of the equals, so to solve for E, type this in the calculator exactly as you see it. The result is 2.7 times 10 to the 21st power, and we're told that that energy is measured in ergs. Number 11, a certain radioactive material decays at a rate given by this equation. We're told Q is being measured in grams and T is in years. If Q sub 0, meaning the starting quantity, is 500 grams, find the value of K if Q is 450 grams after 1,000 years. Because this material is radioactive, as time goes by, some of the mass is converted into energy, and so the substance is reducing in mass as time goes by. After 1,000 years, apparently it has changed from 500 grams into 450 grams. That lost amount of weight has changed into energy over those 1,000 years. We're asked to find K, so we have to be able to substitute numbers into every other variable except where the K is. So for the letter Q, fill in 450. For Q sub 0, fill in 500. In the exponent of the 10, there's a negative, then the K, and then for T, fill in 1,000. As we start to solve this, we could divide by the 500 to get the 10 to the exponent part alone. This makes 0.9 is equal to 10 to the negative 1,000 K. The variable is in an exponent. How do you solve for a variable when it's in an exponent? That's the reason for the log function. Take the log of this side and the log of this side. To find log of 0.9, use your calculator. Push the log button and input 0.9. The calculator says negative 0.0457. It actually has more numbers than that, and you can keep all of those numbers on your calculator screen. I'm just going to write down 4 of them though. When finding the common log of a power with base 10, you just get the exponent. Then to get K alone, we can see that we divide by the negative 1,000. This decimal is still on the screen of my calculator, so I'm going to push the dividing key and then negative 1,000. And the answer for K is 4.57 times 10 to the negative 5. I did some rounding on that decimal. Number 13. A certain type of bacteria grows at a rate given by this equation. This number right here for the exponent is really hard to read, so let me write that with my pen. It's T over 48. We're told that N is the number of bacteria, and T is the amount of time that's gone by in hours. How many bacteria, meaning solve it for N, will be present after 3 hours goes by? So use that equation and replace the T with 3. All of the numbers are on the right side of the equals, so to solve for N, you just need to type this thing in the calculator. Type it in exactly as you see it. The result is 1,154 if you do a little bit of rounding and just drop the decimal part off. Next, number 17. If X is the thickness of an absorber and K is the absorption coefficient for that material, and I is the intensity of a beam of gamma radiation, then the intensity of the beam after passing through a thickness of that absorbing material is given by this equation. Again, that exponent's a little bit blurry, so let me write that on there with my pen. It's negative Kx. Find the absorption coefficient K by plugging in numbers for every other variable in that expression. So for the letter I, the intensity of the beam, we fill in 100,000. For I sub 0, meaning the starting intensity of the beam, we fill in the 1 million. The exponent is negative K, and then for X, fill in the 9.4 centimeters of thickness. Now we want to solve this for K. Let's first divide by the 1 million to get the power part of it alone. This makes 0.1 equals 10 to the negative 9.4 K. We had one like this just a couple questions ago. To solve for the variable when it's in the power, you take the log of both sides. The log of 0.1 is -1 because 10 to the -1 makes 0.1. The log of this expression is the -9.4k. Then divide by the -9.4 to get k alone. And the answer, if you do a little rounding, is 0.106. Last question, number 19, takes us back to a compound interest situation. How long will it take? So it's t that we don't know. $1,000 is invested. That's the principal. 4% means r is 0.04. Compounded quarterly means 4 times per year. And we want the money to double itself. So if you start with $1,000 and you want it to double, then you're interested in when A is equal to $2,000. Let's make our substitutions. 2,000 for A, 1,000 for P, 0.04 for R, 4 for N. And it's the letter T that we don't know. Next step, you can divide by the 1,000 on both sides and get 2 is equal to, and inside the parentheses, type that in a calculator to get it as a single number. It's 1.01. Now where's the variable? It's in the exponent. So how do you solve an equation where the variable's in an exponent? Take the log of both sides. On a calculator, we can find the log of 2. Push the log button and then put in 2 as the argument. And the answer is 0.3010. It actually has more numbers, which I'm going to leave on my screen. On the right side, when you find the log of this power, you can put the exponent in front of the log. Next, we can divide by the log of 1.01 on both sides. That will get the 4t alone on the right. So this number right here is still on the screen of my calculator. I'm going to push divide and then type log 1.01. The result is 69.66. It actually has a few more digits. I'm only writing this many down. Then divide by the 4. And the result for t is 17.4 if you round off all those extra decimals. T is being measured in years. For this particular investment opportunity, it will take more than 17 years for the money to double.